Okay, so dividing, just like yesterday, you're going to divide the coefficients. So big numbers out in front, you will divide those as normal. What was that? Coefficients. There you go. Then use the quotient rule to divide the insides. Remember yesterday was like multiply your outsides to outsides, insides to insides. Same thing today. You got the nth root of a divided by b. We are hoping that in most cases it's going to divide evenly. Sometimes it will, sometimes it won't. And then of course, because this is what this unit is all about, is then you have to simplify the radical. So outsides to outsides, insides to insides, we're doing division today. When I've got this one, I first do 36 divided by 9. That gives me 4. Okay, now I divide the insides. Oh, that's not a highlighter. This one is. 1,250 divided by 2. You can use a calculator, it doesn't bother me. 625. So remember, this is a fourth root. So fourth root of 625. So you have divided the coefficients. You have divided the insides numbers. Fortunately for us, they divided evenly. And now you're going to look at your perfect chart and see what you know about 625. And I want perfect fourths, so make sure you're looking at the right column. What do you notice? It is a perfect. What is the fourth root of 625? 5. Not going to mess this up today. Okay, so you get 5. Straight up, just 5. So that gets you what? 4 times 5. 20. Well, it's going to get harder. It's algebra 2. Okay, that's a basic one. We got division again. So this is where we talked about number 17. When I have division, I subtract my exponents. Yesterday you added because of multiplication. So today you want to make a note. This is division, so you're going to subtract your exponents. All right. So I've got x to the third over x squared. So inside, I would then have x to the first. And then subtract 9 minus 5, because they have the same base. It's y to the fourth. This is a square root. So we're going to try and think about, again, what's perfect, what's left over. You have an index of 2. Can 1 divide by 2? No. It's a leftover. Can the exponent of 4 divide by 2? Yeah, that's perfect. 1 can go into 2. I'm asking, can you do 1 divided by 2? If it's a smaller on the inside than the index, it doesn't work. So since I've got a square root, to evaluate that, I do 4 divided by 2. It's y squared. And then you've got the square root of x. I don't think there's a number in front or anything, yeah? No. Okay, this next one looks like it's going to be terrible. Because 7 does not divide evenly by 64, no matter how you try to look at that. You also have different bases. So you cannot subtract the 5 minus the 6. It's not going to help you. But look at your perfect chart. What do you notice about 64? It's a perfect. We're not going to be that mean to you, okay? Yeah, you can split this up as 2. That's always allowed. Everything that you see here is perfect. I'll highlight it in red. That's all perfect, okay? So what is the cube root of 64? Look at your chart. What is it? Cube root of 64 is 4. And the cube root of y to the third is y to the first, or y. Okay, so that one is done. Oh, should I do it in black? Not done. I can simplify the top. Sorry. Oh, geez. Guys, I don't know why I changed it to y to the third. It's not y to the third, is it? Golly. Y to the 6 would make more sense, because that's what you had. Okay, so you did 6 divided by 3. That'd be y to the second. I'm sorry. Okay. The top can simplify. 7 cannot. They can't divide by any perfect cubes. 8 would be your only option, and that's too big. What about x to the 5th? You can break it up as x to the 3rd. Yeah, so the perfect would be x to the 3rd. Not gonna mess it up this time. And then we just talked about how you can't do anything with the 7, so nothing there, but you've got 2 left over. 4y squared. Okay, cube root of, sorry, that's really small. Cube root of x to the 3rd would be x, because 3 divided by 3 is 1. And then you've got, this is your leftover, so it's going to stay. Nothing to do with the 4y squared on the bottom. You cannot simplify anything else, so you're done. So the name of the game is apply the rule. If you've got exponents, you'll subtract them if it's division, obviously. And then simplify anything you can. We're going to move on to rationalizing, which is maybe easier. Maybe. Okay? It sounds weird, but it might be easier. Okay, there is a rule out there that mathematicians decided that you cannot have a square root in the denominator. So for that reason, we rationalize. So you're going to multiply the numerator and the denominator by the conjugate. That's not right. Just kidding. That's on the next page. We're doing really good today. Bottom radical is what I actually meant to say. So whatever radical you have in the bottom, you're not allowed to have one, so you need to multiply